guys, welcome back to chapter 10. We are going to talk about our last intermolecular force and then just do a quick summary. The last intermolecular force is the strongest one. It is the probably most intuitive, easiest one to understand. It's also the one that's the hardest to test on. So I am going to tell you guys about this one, and we'll actually see this one come up later in other chapters more than we'll talk about it in this chapter, but let me at least introduce it. The last intermolecular force is called Ion-Dipole. So this is an attraction between ions and polar molecules. So again, it's a little bit of an exclusive category. We have to have a polar molecule, so that's going to be one of the things that has to be present. And then the other thing that has to be present is an ionic compound. So just as a refresher, ionic compounds are going to be a metal bound to a non-metal. And remember, there's a transfer of electrons, so a positive charge is connected to a negative charge. When we have this ion-dipole attraction, what happens is the polar molecule actually kind of scooches in and separates that ionic compound. And it does something called solvates or surrounds it based on that positive and negative attracted to one another. Okay. So the strength of an ion-dipole bond is one of the main factors that determines solubility. So when we talk about solubility a little bit more in the next chapter, we will come back to this idea. So what we see here is sodium chloride in water. So we know sodium chloride dissolves in water, but have we ever considered how or why that happens, right? So we've got our sodium chloride molecule. That's this purple and green thing over here. Sodium chloride is an ionic compound. They transferred electrons, positives attracted to negative. When we drop sodium chloride into water, what happens is this water starts to tug on the chlorine. The water starts to tug on the sodium, right? And eventually there'll be a strong enough tug on those that they'll separate from one another. So chlorine and sodium will separate. And then we're going to get this solvation process. So for our sodiums, we've got the partial negative from the oxygen surrounding that sodium. So all the oxygens are facing in. And over here on our chlorine, we've got the partial positives from the hydrogen side that surround that negatively charged chlorine. So all the hydrogens are facing in. And this process just rinse and repeat all around that container. Okay. So ion-dipole, like I said, is the strongest of the intermolecular forces. It's the strongest because we're not looking at partial attracted to partial. Here, we're looking at partial attracted to one whole positive charge, partial attracted to one whole negative charge. So that makes it a little bit stronger. So ion-dipole is the strongest of the intermolecular forces. It's also one of the hardest to test on, make questions about. So just know that it does exist. So here's a summary of our intermolecular forces. I got a couple different slides that summarize them. Remember, this is a hierarchy list, so the weakest at top, the strongest at the bottom. Here's a link to another video. So this is somebody that wrote our textbook in the past. He just does such a great job of explaining things. So I have linked his video in here as well. And then here's just a description of all of the same things, but in words. So just having this summary slide to take a look at. That concludes our introduction to intermolecular forces. What we're going to do with the rest of the chapter is apply this, right? So we're going to rank intermolecular forces based on a series of molecules. Or we're going to talk about a property like boiling point and melting point. How does that affect, or how is that affected by intermolecular forces? And then we can rank them based on intermolecular forces, which has the highest boiling point, which has the lowest boiling point. So step one is going to be able to determine what intermolecular forces are present, and then from there we'll apply it to a different series of situations. I hope you guys found this helpful.